So what I did was I took the malware analysis virtual machine monitor that was written by a bunch of students at Carnegie Mellon University. It was actually originally based on this academic one called Tiny Virtual Machine Monitor. And I took it and I actually modified it such that it'll take the platform system mode interrupt handler and it'll run it inside of a virtual machine. The way it works, and so over here we have our serial output. I'm going to run it again. There we go. Okay. So you can see SimNow is running. It's reinitializing everything. I'm just using the BIOS that came with right now. I had a modified version of core boot. The thing you're going to see with this is I'm going to virtualize the system mode interrupt handler, but I have a little bit of bug. I have one bug in my code involving paging and the shadow page table such that when the virtualized SMM handler runs, I'm getting the general protection fault you can see on entry. So I just need to fix some of that code right there to make that go. So all right, so here we are. So BIOS is booted up. I'm now going to run MAVMM, which is going to virtualize this environment right here. So what's going to happen is I'm actually going to save the state of the system right now at boot with grub, copy that into a virtual machine control block, and when it goes into the virtual machine control block and VM run is run, we're actually going to come back to grub again, because except this time we're going to be operating inside of a virtual machine. At the same time while I'm loading this, I'm also mapping SMRAM, copying all of the contents of SMRAM, putting it on a bunch of other physical pages in DRAM, making a virtual machine out of that by defining a virtual machine control block, and setting the appropriate intercepts that we covered in those slides that I sort of raced through. And when that's done, what's going to happen is that every time the guest gets a system mode interrupt, I intercept it, I go through all the steps I just talked about, and I invoke the original system mode interrupt handler in my virtual machine. And let's do this in a sec. So all right, so here's this console over here. Go. All right. So, going through all this, we check all of this, we boot Mavim, it figures out where all physical memory is. Our VMM code ends over here, is mapped at 800,000, or, yeah, sorry, 8 million hex. We initialize all of this, we get it, or we have our VMM memory allocation set up. We figure everything out in terms of the features. We create our guest, like I told you, where we save the state of grub at boot. Load everything else. We build our page tables for both the guest here and for the SMM VM. All right, and like I said, so we get all of this. We boot through. We go to grub for the second time. This is my output right here, just to make sure that I'm actually getting through the sort of loop. And then I end up switching to page real mode because I actually caught an SMI. At which point, I then run the virtual machine, but as you can see right here, the SMM handler is causing a VM exit, and this is the general protection fault that I told you about that I need to fix in order to get the demo complete and able to handle non-trivial system mode interrupt handlers. So I'm pulling this right now out of the BIOS, or out of the SMRAM. So right here, you can see that I got the protection fault. I need to figure this out, but I resume it again. At which point I move it forward a little. I move the instruction pointer forward a little bit, and I actually get the RSM instruction, which I then trap back from the SMM VM. And currently, right now, I'm running what I call my test OS. It's just an instruction that jumps onto itself. So there's nothing real. I just need a guest to just constantly run in guest mode. And that is my demo. And that's sort of my talk. So actually, so basically what happened, like I said, was we caught the SMI here in guess A, which is what we had after grub. We immediately come back to right after where we ran the VM run instruction. I check the exit code and I go, oh, I got an SMI. And from there, I do what's called SMM VM prep, which is map SMRAM, set up the page tables, get everything going. Call VM run on that again, which then puts us in our guest SMM. In this case, I got another exit, which is for the general protection, keep it going, and I exit out again when I get the RSM after. So if you're trying to build a secure system and you actually have to do all of this, you do need some cooperation from the BIOS, which is, like I said, to make sure that you can actually unlock SM lock. Otherwise, you can't really do any of this. And so as part of this, you sort of have to bootstrap a virtual machine monitor. You can use like SK-init to actually do this after the fact, provided that the BIOS has agreed to let you unlock SM lock using the SM key, MSR. So what happens with SK-init is it's going to stop all their processors other than the bootstrap processor, which is the one that invoked the SK-init instruction. Reinitializes processor state as if a reset had been asserted, and then you can use like minus some of the SM lock stuff. Though I need to check on that again. And then you can use like device exclusion vectors to keep like DMA and other stuff away from you from being hurt, like attacked. But the most important thing about this whole thing is that when you're loading it, the global interrupt flag is set to 0 while you're running SK-init code until you, as software, unset it. And that way, your secure loader, which then loads your virtual machine monitor, it can actually do all of this atomically, and so you don't have to worry about like system mode interrupts getting taken or handled while you're trying to do all of this. As well as you get the added advantage of having the ability to verify the integrity of the secure loader, like by using the TPM. So I quickly looked at a lot of the stuff that would be, like, I looked at Intel's VT to figure out how they were doing this as well. The technologies are conceptually very similar. Important things that are sort of different are like the VMCS, the virtual machine control structure that Intel has. It's a variable length data structure. And not all features seem to be supported across like everything that supports VT. Again, the other thing I couldn't find was an explicit intercept for system mode interrupts defined in the data structure. I need to look again just to make sure that's correct. But when I looked through the manual, what they had was they had normal treatment and they had dual monitor treatment. Dual monitor treatment is essentially what we talked about earlier, which is you can put another hypervisor inside SM RAM. They have another model-specific register that you can use to map SM RAM, sort of the same way that SMM CTL lets you. The thing is, not all VT hardware supports it, so it's like the second or third sentence in the section. And I have to look at more at how that works and more of like the interplay between that. The other thing too that's kind of important is that Intel's VT uses virtual 8086 mode to virtualize real mode code. And sometimes you need other code to sort of virtualize real mode code. This is where you get things like VMX assist from Zen in order to boot operating systems and whatnot. Anyway, thanks for coming. Thanks for coming to Shmoocon. Any questions? All right. The question was, is this stuff actually being used in any Harris products, or was this me trying to figure out how to containerize SMM? The answer to this is that the research I was originally doing was to build that other VMM, and that was an SBIR that we had back when we were Crucial Security. This is sort of an offshoot of that work because I saw the Invisible Things Labs talk last year at Black Hat DC and sort of realized, like, oh crap, this may be a way to get at our keys and start decrypting stuff. So all of this right now is completely sort of academic stuff that I've been doing with Harris, but sort of on the side as well. Mostly so we have the research so that when we do get back to developing that product, we can actually like take care of this threat.
Do you think there's any commercial hypervisors which are actually trying to do this kind?
Commercial, I haven't really looked at a lot of the commercial stuff. Everything I've looked at has been the open source stuff because it's available. So I can't speak to like Hyper-V or any of that stuff. The platform does support it and is one of the design features. I'd have to look at it to figure it out. Anyone else?
Have you read or I guess what would be your thoughts on the implications of this for the SMM rootkit that came out in Frac? Does this effectively manage that end up being problem in the virtualization?
If I remember correctly,